Let's review quick here. Standard form of quadratic equation is there given to you. What can we do? So just looking at this equation, recall what's everything we can do from this equation. Pause the video, think about that, write your answer down on your guided notes worksheet. Seriously, if you haven't paused the video, definitely do it now. And here are, you might have come up with more, but here's what I came up with. Go ahead. If you didn't have anything written down, or if you had other stuff written down than that, make sure you add that to what you have written down. And we'll share and talk about our answers tomorrow. (5.3) is over the vertex form of quadratic equations. Y equals a times x minus h squared plus k is the vertex form, where hk represents your vertex. H is the x coordinate in your vertex, and k is the y coordinate in your vertex. Okay, so today we're going to talk about how to graph functions when they're in vertex form as opposed to standard form. It's actually pretty much the same exact steps. We need to find the vertex, find the y-intercept, and create the table just like we did, and we need 5 total points. So it's all kind of the same stuff. The only difference is it should be a little bit easier because we don't have to actually calculate the vertex. We can determine the vertex just by looking at the equation. So let's walk through this first one. Okay, we're going to look just in the center part. I know you might be a little overstimulated with everything you see there. We know y equals a times x minus h squared plus k is the vertex form. So of this, we know that a is 2. We also know that h must be -1 because the only way this can be +1 here is if we do minus a -1. And then k must be -4 because the only way we can make this -4 is if we add a -4. So because of that, my h is -1, my k is -4, therefore my vertex is -1, -4. So I started my table off over here with that, and I plotted my first point. Then just like we did with standard form, let's find our y-intercept. Now this will be a little bit harder than it was in standard form, because remember standard form, all we had to do was look at our c value and say, oh, boom, that's our y-intercept. So it's 0 that. Well, not necessarily the case here. We have to actually physically plug 0 in. So when we do that, we'll have 0 plus 1, which is 1. And then we have to square 1, which is still 1. And then take 1 times 2, which is 2. And then 2 minus 4 is -2. So we're going to get the y-intercept of 0, -2. And then let's plot that. Okay, there's 2 points that we need. Now we can plot the y-intercept's corresponding point, because remember we have to correspond around our vertex here. So this is 1 unit away from our vertex. So also 1 unit away from our vertex is going to be here at -2, -2. So we'll plot that point. And then we need 2 other points. So let's plot 1 point and then its corresponding point. Okay, so if you want to look at the green to find the other point, I said, all right, well, let's just pick a value, an x value, which was 1, and let's plug it in. 1 plus 1 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 4 is 4. So when x is 1, y is 4, so I plotted the point 1, 4. And then I also plotted its corresponding point. Since this is 2 units away from our vertex, its corresponding point also needs to be 2 units away, which is here at -3, 4. So there's our 5 points. So I can plot our parabola, or graph our U-shaped graph, our parabola. And there it is, the graph of y equals 2 times x plus 1 squared minus 4, right here. Let's go ahead and try example 2. Now, I know on your notes, I have example 2, and then I put if needed. So what I mean by the if needed, you need to sit here and read or watch this example, but you don't necessarily need to write it down if you feel like you have it. But I do want you to pay attention and watch. I actually kind of want you to try this one on your own first. So go ahead, try to find the vertex, try to find the y-intercept, try to come up with a table. If you want to actually go to the chalkboard and do this, Go ahead and do that. That way, or do it on a scrap piece of paper. I don't care how you do this. Just go ahead and do it if you don't want to write something down wrong. But go ahead, try it yourself, and I'm going to put everything up on the board here for you in a second to see your answers. Okay, this one gets a little bit crazy because our points are really far away. So we have our vertex of -7, -8, a y-intercept of 0, -155. Because 0 is 7 units away from our vertex, I have to go another 7 units away, and we get -14, -155. And just so we didn't have to graph anything even bigger, I wanted numbers in between 0 and -7, so I chose, I don't know, -3, and got -56. If you chose something else, like -2, -1, -4, -5, -6, any of those would work. Obviously, it's going to be a different y value, though. So -3, -56, and then -11, -56 for your ordered pairs there, or what I got. Again, if you have your vertex good and your y-intercept good, and your y-intercept's corresponding point good, I'm sure these two are good as well. If you want to know for sure, you can have Mrs. Gwynn or the sub or someone else check for you. But there's that. You have a question like this on your checkpoint or on your quiz that you need to complete as well. That quiz will be for homework if you don't get these notes done in class. Okay, here's a different kind of example. With this, we need to write quadratic functions in vertex form. We might be given a graph, or at least we're given points that are on a graph here. So like example 1, we're given that this parabola has vertex at 2, 3 and another point at 4, 1. So what do we need to write a quadratic equation in vertex form? Well, remember, vertex form is y equals a times x minus h squared plus k. The y and x, just like in standard form, we want a y and we want an x. So we don't want to change those values. What we want to know is we want the a value. So what's a? And we also need to find our vertex. So what's hk? So basically, what do you need to write a quadratic equation in vertex form? You need an a, and we need an hk value. So, and we're given all the information we need here to determine those, to figure those out. So the nice thing is just by this, we're given the vertex, so we're given the hk. So we know h is 2 and k is 3. So then the question is, okay, how do we find a? And let's walk through that. Okay, so here's what we have. Great, but we don't have enough. We need a, like I said. So how can we think about it? We're given this other point for another reason. We're supposed to use this point to find a. So think about just in general what graphs mean. When a graph crosses through a point, it means that point is a solution to the equation, meaning that it makes that equation true. So we need to use this point, plug it in for x and y, just for right now, to find that a value. Then once we find the a value, we can write our equation and x and y go back to x and y. So let's work through this example. Okay, so let's direct our attention to the blue ink here. So y is 1. We still don't know a, but we know x is 4. And we know that that makes the equation true. So let's simplify this right-hand side. 4 minus 2 is 2. Then we have to do exponents, so 2 squared is 4. The biggest mistake people make here is right here. They then try to add 4 and 3. You cannot do that. This is a times 4, or 4a. So basically right here we have the equation 1 equals 4a plus 3. 4a plus 3 we can't combine because they're not like terms. So we have to get rid of the 3, and we're going to do it by subtracting 3. So we do that, and we get -2 equals a times 4, or -2 equals 4a. Divide both sides by 4. And then we get a equals -2/4, or -1/2. So we have our a value. We have our hk value. Now, if we direct our attention to the red ink, we can write our vertex form. Y equals a, which is -1/2, parentheses, x minus h, which is 2 squared, plus k, which is 3. So there is our equation in vertex form. If you need to go back and rewatch this, please go ahead and do that. Here is another example. Again, with this, I want you to try it. Again, you can go to the chalkboard and try it. You can do it on a scrap piece of paper. If you don't feel confident in it at all, then you don't need to try it on your own, and you can just follow through and definitely write it as example 2. Again, this is another one of those example 2 if needed. Now I know this is a little bit more confusing than the first problems we worked through, so I understand if it's needed. Now with this, really quick, you might say, well, hold on. The last example, you gave us a vertex and a point. Here, you don't have any of that. Wrong, we have all of it. It's just not telling us, hey, your vertex is this point, hey, your other point is this point. We have to read the graph and say, oh, my vertex is at 1, 2, 3, 1, 2, 3, 4. Oh, my vertex is at 3, 4. And then my other point here is at 5, negative 4. So you have everything that you did in the first example. So go ahead and try that. There's all of the work you need for this example. Again, we need to know what A is, what HK is. We're given HK by our graph, so we walk through it here, and you end up with this blue equation. If you have questions or don't understand how, again, ask someone around you or ask the sub, and they might be able to help you out. Thank you, and you do have a problem just like this on your quiz as well that you need to complete for homework, or you can complete in class as soon as you finish your notes. Okay, here we have a task again of writing the equation in vertex form. However, instead of giving points on the parabola, we're given the equation in standard form. So again, what do you need to write an equation in vertex form? We need an A value and we need an HK value. So we need an A and we need a vertex. And if you remember, standard form is y equals ax squared plus bx plus c. So we're actually given A in the problem. It's ax squared. So A, for example, 1 is 1/2. And then remember back to 5.2, well, how did we find the vertex of something in standard form? We did opposite b over 2a. So you're going to have to use the a value that we're given and then opposite b over 2a to find the vertex for each of these. And then once we have a and once we have hk, we can write our equation in vertex form. We already know a is 1/2. So let's go work through the math to find the vertex. Okay, so opposite b over 2a is negative 4, since b equals negative 4, over 2 times a, which is 1/2. So negative 4 is 4. 2 times 1/2 is 1. 4 over 1 is 4. So remember, that's just the x coordinate of our vertex. That's just h. We need to plug it into the original equation to find k. So we do 1/2 times 4 squared minus 4 times 4 plus 16. 4 squared is 16. 16 times 1/2 is 8. 4 times 4 is 16. So we have 8 minus 16, which is negative 8. Negative 8 plus 6 is negative 2. So our vertex is 4, negative 2, or our HK is 4, negative 2. So we have our A value and we have our HK value. Now let's plug it into our vertex form. Y equals A, which is 1/2. Parentheses x minus h, which is 4 squared, plus k, so plus negative 2. Or we could rewrite it as just minus 2, because that's what plus negative 2 is. So either one of these answers would suffice for your vertex form equation. So why don't you go ahead, pause the video, and try and do example 2 here. Y equals 1/5 x squared minus 20x plus 5. Again, try and write that quadratic equation in vertex form. And there you have it. Y equals A, which is 1/5, directly taken from our standard form equation. Once we do opposite b over 2a, we end up with the h value. The x coordinate of our vertex is 50. Plug that in. 50 squared times 1/5 minus 20 times 50 plus 5 is negative 495. So your vertex form equation is y equals 1/5 times x minus 50 squared minus 495, or plus a negative 495. And again, on your quiz, you have an example of that, or you have a problem just like that to do as well in your checkpoint quiz. You'll find that checkpoint quiz under homework. because that is technically your homework. If you get the notes done in class ahead of time or with time left, you can complete the quiz in class. Otherwise, it is homework.